Okay, the equation would be 1.5 divided by the 3. Okay, now this is a calculator question, so we can put that in our calculator. 1.5. The times 10 to button is down the bottom in the middle for me. Okay, so times 10 to the 11 divided by 3 times 10 to the 8. Okay, giving us 500. Okay. Or says it asks for scientific notation. You could write it like that if you want. 5 times 10 to the 2 seconds. Okay. Remember that times 10 to is just how we're moving that decimal along. Any questions on that one? Okay.
See, going through all of these, it makes me feel stupid that I didn't get all these marks because it just seems so straightforward. But at the time, you're like, oh, I don't even know how to start that or whatever.
And that's it comes down to exam practice and going
Yeah, you
through
learn
the
from
past
it,
papers and stuff.
absolutely.
And that's what we've not done. So we've tried so hard to get everything done to a date to allow us to do the prelim. We never got to do exam practice.
Yeah.
So that was quite apparent. All right. Okay, so no, not that one. Question 3, the love and angles question. Okay, the love and angles question. Okay, I must have an old one. That was actually 42 in the test, so they changed it. Okay, let's go through the rules that we've got in front of us. Okay, and the lines that we've got in front of us. So, let's have a look. D to E is a diameter, so it's cutting right through the middle there. Okay, so that's an important line. F to A is a chord. Okay, so there's rules that we want to know about the chord. Now, importantly, these two wee arrows mean that those lines are parallel to each other. Okay, they're pointing in the same direction. That's what those wee arrows are telling us. Okay, so I don't know, we might have covered it very, very briefly. Okay, don't know how many questions I would have went over with parallel lines in it. That's all that means, that those lines are running in line with each other. Okay, doesn't actually help us with the question any, but it's just good to know. What else are we given? Well, we're given this angle OAC. Okay, in between, coming from the origin to the outside of the circle, so it's coming from the middle to the outside, so that's a radius. Okay, from the centre of the circle to the outside edge gives you a radius. Okay, also connects to that chord. And I've put a line from O to B that also cuts through that chord. Okay, so that goes from the middle right through. Okay, so that cuts that chord at a 90-degree angle. Okay, so start putting in things. Start putting in angles that you're aware of. Okay, so that's a 90-degree angle in there. That's a 90-degree angle in there. Okay, now what else have we got? Well, we've got A to B. That A to B line is a tangent. Okay, it tells us down here, AB, line AB is a tangent to the circle. Okay, that means that tangent in that radius where that meets creates a 90 degrees. Okay, so that's one of the rules. I'll tell you in 2 seconds. Okay, that's one of the rules. So that radius where it meets the tangent creates a 90 degree angle. Okay, that allows us to take that, I think it was 42. I don't know why I've got an old paper here, but we'll just keep it at 48. It's the same process. Okay, that allows us to take that angle, that 48, and do 90 minus 48 to equal 42. Okay, so it equals 42. That means that angle in there, is 42 degrees. Okay, now that comes from the knowledge of that radius where that meets the tangent, creating a 90 degree angle, which means we just need to take away that 48 from 90 to get the missing part. Okay, now that leaves us with this right angle triangle, and the knowledge that the 3 angles in a triangle equals 180. So that missing angle that it's asking for, angle OAC, or what? Angle, oh, I'm not reading the question, that's all. Stop that. Why is that not allowing me to scroll? Oops. No. Calculate angle ABC. Okay, so that angle there. My God. That angle there. Okay. Is going to be 180 minus our 90 minus our 42. Okay, that gives us 48. Okay, so the final answer is 48. So it took us to know 2 things. Okay, that line coming from O to B is going to cut through that chord at 90 degrees and create a 90 degree angle there. Okay, it took us to know that this radius where it touches the tangent is going to create a 90 degree angle, which allows us to find this missing part. Okay, and then when we're finding ABC, take them away. Okay. Any questions on that one? What section was that? What section was that? 18.2. Okay, again, can go a lot of places. Okay, they cannot go a lot of places with this. Okay, this angles and circles. It's just 3 rules. Okay. That's the rule. A radius meets a tangent, it's going to create a 90 degree angle. Okay. For standard deviation, mean and standard deviation. Okay, so mean is the average So the mean is all of them added up and divided by the number. Okay, so 11 plus 19 plus 9 plus 11 plus 14 plus 8 divided by 6. Okay, to get us the mean. Okay, then it's about using the equation, the standard deviation equation, and creating that table. Okay, so let's have a wee look. So our numbers 11, 19, 9, 11, 14, and 8. Okay, we write the mean as x bar. Okay, and that's adding up all those numbers. Do it in your calculator or do it in your head. Okay, 30, 40, 50, 64, let's see, 72 divided by 6. Okay, so the mean is 12. Okay. Now we put that in a table. Okay, so we create a table for standard deviation. Okay. We've got x in our first column. All our numbers. The numbers don't have to be in order. 11, 14, and 8. Okay. X bar is just the average. So I'm only putting that column in there as a reminder. Because the next column is your x minus x bar. Okay, so that column is just 11 minus 12, and it gives you the answer. Okay, so 19 minus 12, 9 minus 12, 11 minus 12, 14 minus 12, and 8 minus 12. Okay, and your last column is x minus x bar squared. Okay, so it's this number. Okay, so those numbers squared. So when you square a negative, it becomes a positive. So negative 1 squared is 1. 7 squared is 49. Negative 3 squared is positive 9. Negative 1 squared is 1. 2 squared is 4. 16. Okay. We do this column because we need to add up all of those numbers. Okay, because it makes up part of our formula. That cut out there. That's all, guys.
You did a wee bit, but it was just for a second or so.
Don't know what laptop sort of disappeared on me. Okay, so we need to add up all those numbers because we need to use that in our formula. So I'll just add up all these numbers. So 1 plus 49 plus 9 plus 1. Okay, that's 60. Plus our 4, 64 plus 16 gives us 80. Okay. That wee symbol there is a Greek letter sigma. Okay, capital sigma. All that means, that wee symbol there, is just sum of, so it's adding them all together. So that symbol, sigma, means I've added them all together. That's what that means. Okay, so the sum of x minus x bar squared is 80. Okay, so I've just added them together. Why do I need this? Standard deviation formula, which we get at the start. Okay, is the root of the sum of x minus x bar squared over n minus 1. That's what we've just found out. That's that. Okay, so I just put that number 80 in that part of the equation. Okay, so the equation becomes root of 80 over n, which is the number of numbers, if that makes sense, which was 6, minus 1. Don't ask me why minus 1. Okay, so root of 80 over 5, which you can put in your calculator now, or, yep, Francesca.
Do you have to write the what you call this, the formula to have a mark on that, or can you just like go straight and like write 80 and then
I would write the formula because it's, you get given the formula, so I'm going to say no, but it's a reasonable question. That, honestly, I'm not even going to look at the marking scheme. Show it. Show you're working, because a lot of you never showed working. The factorization question, a lot of you just put the answer, which it's fine, but some of you got the wrong answer, so I don't know where it came from. All right, always show you're working. You do get marks in some questions for working. So just show it. It takes 2 seconds to write down. Okay, so 80 over 5 is 16. Okay, so it's root of 16. Root of 16 is just 4. So your standard deviation is 4. Okay, bizarrely, the next part of this question, part B, people seem to answer okay, even though the actual standard deviation process was a bit all over the place. Most people seem to get the mean. Most people attempted the table, and then got to putting it into the equation, and then went a wee bit awry. Okay, so most people picked up 2, maybe 3 marks here. Okay, but went a wee bit skew with at this point. Okay, so that 80 just goes right in where it says sum of. Okay. So that higher number, so in part B, let's go part B. In part B, it said make 2 valid comments. So if the number for the standard deviation is higher than that, then it's more variable. Okay. If the mean is higher, does it mean higher? Mean was lower. Okay. It means on average. Okay, so the mean is on average, so that's what they're looking for. So the mean was 12, so on average, what's her name? Jane's phone calls were shorter than Tim's. Okay, that's, most people did that okay, had a stab at it and picked up the marks. Okay, 2 easy marks. Any questions on standard deviation? Remember the equation at the front of the paper? In fact, I'll show you that. So that was section 26.3. Bum, 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 26.3. Yeah, okay. So again, there's nowhere else they can really take that. They'll ask you the mean, they'll ask you to find the standard deviation, and they'll ask you to compare it. So you're comparing the average, i.e. the mean, and the spread of data. Okay. There's nothing else there. There's nowhere else they can take that. This interquartile aspect, they never removed the whole thing. The likelihood of this coming up is slim because they've removed enough to make it, a very small question, put it that way. Okay, there's not a lot of scope of where they can take that. Now, you need to be aware of it and what the interquartile range is. Okay, but it's just splitting your numbers into 4, your interquartile ranges. Okay, Q2 is right in the middle, Q1 is half again, Q3 is half again. Okay, that's all your quartiles are. They're not removed at all, or they were quite ambiguous with the statement in regards to quartiles and interquartiles. So be aware of it, but the bigger chance, the most likely question to come up is that standard deviation. Okay, and it's worth 6 marks. Okay, considering the whole paper, I think was 50 out of 50 marks, that's 6 marks out of 50, that's 12% right there. Just known standard deviation. Okay. Any questions on standard deviation? No. Triangles. Right, triangles. Got a bone to pick with you. There's a difference, or we looked at 2 very different types of triangles and applied rules to them. We applied rules to right angled triangles where there was a 90-degree angle, and there was rules, the Pythagoras rules, a squared equals b squared plus c squared, okay, and the SOHCAHTOA, okay, the sine equals opposite over hypotenuse, only applies to right angled triangles. The other rules, the a over sine a equals b over sine b, and the cos rules apply to non-right angled triangles. You need to be very, very, very clear in your understanding of that. Okay. Too many people applied or tried to apply Pythagoras to non-right angled triangles. Okay, so they tried to where a squared is the long side, so your hypotenuse, and your b and your c were your 2 short sides. Okay, that is right angle only. So is this. When we did that, okay, they are for right angle only. Okay, where there's not a right angle, where there's not a 90-degree angle, we use these rules. Where your capitals are your angles, and your small letters are your pairing sides. Okay, remember we looked for matching pairs. So that's the term I used, matching pairs, and we'll go through what that means. Okay, so you're either using that or the cos rules that you're given in the exam paper. Okay, so your non-right angle rules you're given at the front page. Okay, in the formula list. So your cosine rule and your sine rule only applies to non-right angle. Okay, so now I've made that clear. Don't do it again. Right, so what have we got here? We're asked to calculate the length EF, okay? So that is EF, okay? So we're asked to calculate that line there. Okay, so what do we need? No, I'm not doing that. Okay, well, we need matching pairs to be able to find that. Okay, now what rules have we got? We've got the sine rules and we've got the cosine rules. Okay, the cosine rule you're only really using when you've got multiple lengths. Okay, so you need more than one side to use the cosine rule. Okay, we don't have more than one side, so it's pointing towards the sine rule. Okay, what information do we need for the sine rule to work? Well, we need matching pairs. Okay, and a matching pair is the angle and the opposite side. Okay, so if that angle is A, oh, that would be the capital. That is angle A there, capital A. That is side A. It's matching pair. Okay, that angle 131. Okay, if that's angle capital B, then that side there is B. 26, if we call that angle C, then the opposite side to that, EF, is side C. Okay, so your matching pair is your angle and your opposite side. Okay, now that is quite messy, so let me clear that. Okay, now what are we looking for? Well, we're looking for EF. We've got that angle opposite it, so we've got a matching pair. We've got a side, but we're missing an angle. Okay, we don't know what that angle is. Now, do we have enough information on that triangle to work out what that missing angle is? Yes. Okay, all angles in any type of triangle, all three angles add up to 180. So the missing angle is just 180 minus 131 minus 26. So angle DFE, okay, angle DFE is equal to 180 minus 131 minus 26, the two angles that you're given. Okay, sticking that in your calculator. 23 degrees. Okay, so very quickly, very easily, we can find out that angle in there is 23 degrees. And that means we've got a pair. We've got a matching pair. Okay. We've now got a missing side and a matching pair. We can use the sine rule. Okay. A over sine A equals B over sine B equals C over sine C. Okay, so we've got A, which is side. So we call that, what did we call that? 12. Okay, over sine 23 equals B, which I'm missing. When I was scribbling on that, I called the 131 bead in there. And we've got C.
Does it matter what, see on each side, does it matter what you label A, B and C?
No.
No, okay.
So that B is line opposites of DF. Sorry. And that is EF. So that's the side that we want. Alright. So I'm going to rewrite that. 23 equals line DF over sine 131. Okay. That side and that angle is a matching pair. Okay. Now we only need to use one of them. Okay, so if we're wanting to find DF, we would use those two. But we're not. We're wanting to find EF. Okay, so we don't need that part. That's the only bit we need. Okay, so you can remove that. You don't need it. Okay. 12 over sine 23 equals EF over sine 26. Now it's a case of rearranging. Okay, so we're bringing that sine 26 over here. It's a divide on the right hand side. So when we move that across, it becomes a multiple. So it's just 12 sine 26 over sine 23. That's what you're putting in your calculator. Take it to 2 decimal places unless they ask. Okay. So EF. Remember the units. I think you get a mark in that question for the units. Just check the marking scheme. This is what I'm working with. Oh my god, come on. Just didn't open. Cool. Okay, what section was that? Triangles is a big section. Blue wheel of doom. Triangles, triangles, triangles. Section 22.2. Okay, 22.2. Okay, so triangle trigonometry is quite a big section itself. Okay, so section 22, trigonometry. So that first bit there just indicates your matching pairs. So if that's angle A, that's its matching pair. That's angle B, that's its matching pair. Angle C, that's its matching pair. Okay, that's all that's shown there. Okay. That's the rule that we used to find a missing side. Okay. What else can they ask? Well, they can ask, find an angle. Okay, so using the same rule that we just used to find an angle. So they can just frame it slightly differently. Okay, so they could ask it in that format. Okay, or they could use the cosine rule. Okay. Again, you're given the cosine rule. It's just knowing how to apply it. So knowing what A is, B is, C is, and being able to apply it. Okay. The cosine rule, that side A has to be the partner of that angle. Okay, so whatever angle you have, your side you're trying to find out is the pairing of that, your matching pair for it. Okay. Likewise, when you're finding the angle, that A is really important that you get the right length. Okay, really, really important you get the matching pair for it. The small a and the big A goes together. Okay. Again, there's not a lot of places that can take that. Okay. They might ask you in a wee bit of a story, but the story can't really tell you much. Okay. Because they've taken out bearings. So they might put a wee story behind it, but what's that, sorry?
Daniel, can I have 20 minutes because I have to put this little one to bed now?
Can you have 20 minutes?
Yes,
Yeah,
please.
of course.
Thanks.
Place for a break then. Let's do that, guys. We'll kick back off at 25 to, if that's okay. Okay. If anyone, let's resume that. Okay, so what was I going to check there? Oh, units. Okay. So next up, volume. Okay, they love a volume question. Love a volume question. So this is section 11.7. Okay, so section 11. Section 11, remember you get given all these equations. Okay, so in the formula sheet, you get given all these equations. What you'll get asked to do is to find the volume of a composite. So you need to use more than one of them. Okay, so 11.7, volume of composite solids. Now, the other direction they can take this question is asking you to rearrange. Now, this could come up because they're looking for us to rearrange something with a square in it. Okay, so that's a decent chance question 11.6 comes up. All right.
I don't think cylinder was on it, was it?
No, no, there was a cylinder.
Yeah, but I'm talking about the formula. The formula wasn't on the page, was it?
No, you're right. So volume of sphere, volume of cone, and volume of pyramid. The cylinder's not on it for the simple fact it's just a circle multiplied by height. So the area of a circle, pi r squared.
Pi squared.
I expect you to know that because you use it for working out sectors. Okay, so pi r squared is a common area that they'd expect you to know. And work out the cross-sectional area, then multiply it by the height to get the volume of the cylinder. So, good spot. You don't get volume of a cylinder, but you get the rest. Okay, so let's go into it. Okay, so new drug, that doesn't matter. Each capsule is a cylinder with hemispherical ends as shown. Okay, so I think we actually did this one in class. This is probably the first time, I think volume's the first thing I covered. Okay, and I think this is quite a common one for past paper questions. There's not that many questions or directions they can go with this. They like a cylinder and they like to add a sphere to the end of it. Okay, so let's look at the shape first. You've got a cylinder and then you've got two hemispheres that create a sphere. So my first port of call, go to your formula sheet and look at what you're going to need. Okay, so I'll share my screen in a second. The volume of a sphere is 4/3 pi r cubed. The volume of a cylinder you don't get, which is pi r squared, which is your cross-sectional area times the height. Okay, so all I've done is just start my page with these two. Okay, so volume of sphere, volume of cylinder. And this allows me to work out what do we need. We need the radius. We need the radius.
And the height.
Okay, so we need the radius. So let's have a wee look at it. Couple of dimensions we've got. We've got 26 is the overall length. We've got, oh, we need h as well. We've got the cylinder length, which is 14. Okay, the cylinder length, which is 14. So to find the radius, we're going to do 26, take away that 14, and that will give us the full diameter of the sphere. Okay, so if we took away that cylinder completely, we'd be left with a ball. Okay, with a sphere. Okay, so to work out the diameter of that would just be 26 minus 14. So the diameter is 12. Okay, which leaves us with a radius of that for 6. Okay, so the radius we're going to use is going to be 6 millimeters. Okay, so the diameter is 12, radius is going to be 6. So we go back to our equations. Okay, we found that by 26 minus 14 to give us 12, and then divided that by 2 to give us 6. Okay. And now it's a case of just plugging it in. That's it.
You know, that's so annoying because I got the 12 and I think I went back to the end and I just ended up using the 12. I didn't divide it by 2 because I didn't think it was the diameter. Oh, well, I know now.
It's frustrating. Francesca, you're raising your hand.
See, for the formula for the sphere and the cylinder, is it given in the sheet on the
sphere is.
paper?
So this one is. This one.
Right. Okay.
Good to know. Okay, so that the cylinder is just the cross-sectional area of the. So it's just the area of the circle multiplied by the height. Okay, that's what a volume is. Okay, so it's the area of the circle, which is just pi r squared, multiplied by the length of the cylinder. Okay, so you're expected to know that one. Okay, so we use area of a circle in other places. So when we find out the sector, the area of a sector, which has actually been removed, which is a good point. we use pi r squared as well. Okay, but you're expected to know that. So that's just a case of plugging that in. So if we just plug that in, okay, and then put that in our calculator, you get the answer. Alright, so that's just 904.78. Okay, and then the cylinder, which is pi times 6 squared times 14. Seems high. And then the total is adding them together. Is that right? Let's go with it. 904.78 plus what does it ask for? Two significant figures. Okay, so significant figures would be that one, and then we round it. Okay, so 2500. Remember the units. Volume is going to be cubed. Well, that's remember the units and give you the wrong bloody units. Millimeters. Okay. Length, millimeter. Area, millimeter squared. Volume, millimeter cubed. Okay, section 11.7. Question 7. Don't know why this is in the calculator. Usually in the non-calc, or could be in the non-calc. Okay, this is section 8.5. This question was done poorly. 8.5. Okay, so addition and subtraction of algebraic fractions. So this is fractions with a letter in it. Okay, and you can see there's actually quite a lot of places this question can go to. So being comfortable with algebraic fractions is quite an important one. All right. Going by some of the answers, I don't think that's the case. That's 8.5 is where we're targeting. Okay, and it's doing the kiss smile. Okay, we're doing a kiss smile with algebraic fractions. So, okay, so multiply across, and then create a common denominator. Okay, so important parts of this is signs that we use when we're multiplying out, and how we write out the bottom. Okay, now we've got that. There's a case of breaking those brackets and then tidying it up. But getting to this stage caused some problems as well. Okay, so this sign is important. Okay, so that comes right down. Okay, that means anything we're multiplying for that 5 when we're breaking that bracket is multiplied by -5, which means -5 multiplied by -2 becomes positive. A lot of people missed that on just never did it. Okay, another thing that wasn't particularly well done is putting this bottom line into brackets. Okay, so we're doing x minus 2 multiplied by x plus 3. That's what these brackets mean. So this term is multiplied by this term. Okay, so that's what that means. Okay, so we're multiplying x minus 2 by x plus 3, so we have to put it in brackets like that. There's some interesting ways of writing that. Okay, so just breaking that out. Minus 5x plus 10. Okay. Another thing that was done by more than one is you multiplied out this bracket. You don't need to. Okay, that's in its simplest form. The factorised form is the simplest form that can be. You can't simplify that any further. So multiplying it out and try to tidy it up isn't required. So the bottom terms in an algebraic fraction, you do not need to multiply out. We're just looking to tidy up the top. Okay, that's the final answer. Okay, so that could have been in the non-calc, no problem. Section 8, unless there's any questions. Section 8. Question 8 is the circle reflex angle is 10.4. Okay, so section 10.4.
I just went brain dead. I love that as well.
I know.
I just went brain dead.
Okay, so none of this is given in the formula sheet, so you're needing to remember all this. Okay, so length of arc is pi d. Oh, sorry, length of arc. So your circumference, is pi d. So pi times the diameter is your full circumference of a circle. Okay, then you're multiplying it by your angle divided by 360. Okay, so in this question we're asked to find the angle, so we're rearranging this formula essentially to find angle. Okay, so that's your missing angle. Your length of arc equals angle over 360, because 360 is your full circle. Okay, so this gives you a ratio to multiply to find out what percentage of the diameter is in the length of the arc. Essentially. Okay, so question 8. Sorry, that was question 7. Okay. Ignore that bit, that does. Okay, diagram shows part of a circle centre 0, or centre O, sorry. Okay. Has a radius of 7.4 centimetres. So we need that to find out the diameter. Okay, so diameter is just double the radius. The length of the major arc, so the big bit of the arc, okay. If it gave you the minor arc, it would be the small bit. Length of the major arc shown, AOB, is 30.35 centimetres, so that length from A to B. Calculate the size of the reflex angle. Reflex means it's greater than 180. Okay, so remember we went through that, so you've got acute, which is less than 90. 90 degrees is your right angle. Obtuse is 90 to 180. Reflex is 180 plus. Okay, so 180 to 360. Okay. So, length of arc equals angle over 360 multiplied by pi times the diameter. You need to remember that. No if, buts, and maybes. You're given the length of your arc. You're not
What's that?
I have no idea. I don't know what that was. Someone maybe trying to call me? Nah, I have no idea what that was. Okay, so if you can still hear me, I'll continue. Angle over 360. So you're not given the angle times pi times the diameter, which is double the radius, which is 14.8. Okay, now it's a case of rearranging that. Okay, now it's a case of rearranging to find the angle. Okay, so the 360 is divide on the right hand side. So that comes across and becomes a multiple. This bit is multiples on the right hand side, so comes across and becomes a divide. Okay, so we've got 30.35 multiplied by 360 divided by pi multiplied by 14.8 to get your angle. Okay, putting that in your calculator, your angle will come out to be 235.1 degrees. Okay, just be careful putting that in your calculator. Use brackets for the top, then divide it. Now it should work whatever way you put it in, but just be careful. Picking it out. As daft as it sounds, remember the units. The units for an angle is that wee degrees sign. Okie dokie. Right. Chords.
I just couldn't think.
This question is, or variants of it, will be in it. Always in it. Learn it. Okay. Whoa. Oh, sorry guys. Just throwing lights about. That's how angry I was at the answer to this question. Move my plugs under the table. Sorry. Right. Okay. What have we been given? What we're trying to do. As soon as you see a chord question, what you're trying to do is create a right angle triangle. Right angle triangle comes from your radius to the outside edge. Now that length I just drew in, that pink line there is your radius. That is one side of your right angle triangle. 1.9 is given. Oops. Okay. That is your hypotenuse of your right angle triangle. What else are you given? Well, you're sometimes given this length here, or you're sometimes given this length here. In this question, you've been given information to allow you to find this bit. Okay. You have been given 2.8 meters. 2.8 meters goes from the bottom of the circle to where the chord is. Now the bottom of the circle to the centre of the circle is your radius. So that length is 1.9. That means the distance from your centre of the circle to where the chord is 2.8 minus 1.9. So I'll call it A. So A, the length, equals 2.8. Whoa. Minus 1.9 to get 0.9 meters. Now you've got a right angle triangle, you've got the hypotenuse, and you've got one of the sides, and you're looking to find the missing side of that. Okay, now if we take a line from the centre of the circle and cut that cord's getting cut in half if we're leaving a right angle triangle. So that chord's been cut in half. So if we find this length, it means we can find the full length of that chord. That's what it's asking. The width of the water surface. Okay, so we're going to do the calculation to find out this side here. Okay, does that make sense? Okay, so that right angle triangle we created, that was 1.9 meters. That side was 0.9 meters. Whoa. We are missing that side. I'll call S for surface. Okay, right angle triangles use Pythagoras. A squared equals B squared plus C squared. The long side, your hypotenuse squared, equals your short side squared plus your short side squared. Your long side is 1.9 squared. Your long side is always the side opposite your 90 degrees. One of your short sides is 0.9 squared. The other short side we've called S, so we'll just call S squared. Need to rearrange for S. Put that in your calculator. Should get S equals 1.67 meters. S is only half of the full surface area. Okay, what we've just found out is only half of the full surface area. So if we go back to this, we've only found out from here to here. We've only found out that length there. Okay, that full is just double S. Okay, so we're just multiplying it by 2. Okay, so X 3.34. Okay, so section this is section 19. 19.3 specifically, Pythagoras theorem used in circles. This always comes up. And because I've said that, it probably won't. But there's lots of different ways they can give that information to you here. Okay, so there's lots of different ways. They can give you the radius, they can give you the height from the bottom to where the chord is. Pardon me. Okay, they can position the chord in different places. There's lots of ways they can ask it, but essentially it's always asking you to create a right angle triangle and find a missing side. Okay. Know the Pythagoras rules, know how to move them about. This question, 19.5, didn't come up in the prelim. The Pythagoras theorem in 3 dimensions. Good chance something like that comes up. So we'll do that and we'll practice them. Alright. So if they don't ask 19.3, they'll ask 19.5. Okay. 19.3 is a really common question. Chords, create a right angle triangle, find a missing side. Okay. Don't get that wrong. On me. Okay. Drink fizzy juice. 10. 10 is not a right angle triangle. Don't try and make a right angle triangle out of it. Don't try and find any other angles. Don't make anything up. You're looking at that, you have 3 sides and you're trying to find an angle. You're using the cosine rule straight off the bat. Boof. You don't have a right angle triangle, you're trying to find an angle, you've got 3 sides. Cosine rule. Okay. Find your matching pairs. What they do in this question is they give you other letters to throw you. These letters do not correspond to the letters in the formula. So when you're finding angle B, okay, it doesn't match the lettering in the formula. You need to be aware of that, and you need to be clear with that. Okay, so the lettering in the formula is cos A, the capital is the angle, equals B squared plus C squared minus A squared over 2BC. This is the angle we are trying to find. This is its matching pair. Now, don't be put off by the lettering that they use in the question. In the question, you are looking for letter B. That threw too many people. Okay, ignore the lettering. You're looking for matching pairs. Okay, so if you're looking for this angle, okay, in the formula, that is angle A. That is its matching pair. The length opposite the angle you're trying to find is its matching pair. Okay. That is the angle you're trying to find. That is its matching pair. Okay. The other sides, so what B is and what C is, doesn't matter what way round that, they come. Okay. B squared plus C squared is the exact same whatever way round you do that. The important part of this formula is what you have as your matching pair. Okay, so we are trying to find a missing angle. B squared can be 10, C squared can be 8.1. Minus your missing angles matching pair. Your missing angle matching pair. The side opposite it. Okay. So 6.3. Okay, we're wanting to leave that A in its own. That A stands for angle. So we bring cos to the other side. So your angle is inverse of cos times 0.78. Okay, did it ask? It doesn't ask, but leave it in 2 decimal places. Okay. That A is your missing angle. That is its matching pair. Do not be put off with the fact that that says B. Okay, these are just completely random letters. A, V, B, they could stand for anything. Aberdeen, Bradford, I don't even know a city beginning with V, so I don't know why I started it. Vilnius. Okay. Cosine rule and sine rule, when you've not got a right angle triangle, you're looking for matching pairs. The cosine rule in particular, the matching pair is so important you get it right. Okay, if you had those lengths differently, then you're way off. Okay, so 38.9. Okay, so that was section 21.5. Right, question 11. Sketch the graph. It's what we've been doing the last 2 weeks. Alright, you should be doing this. Okay, sketch the graph, and then you're given a quadratic in its factorised form. Okay, so if you broke out that bracket, if you broke that bracket up and multiplied it out, you would be left with a quadratic, x squared, blah blah. Okay, so we're sketching this out. So we're looking for 4 different things. We're looking for the shape of it. Is it happy or sad? We're looking for the roots, where it cuts the x-axis. We're looking for the turning point, where its maximum or minimum is. And we're looking for where it cuts the y-axis. Okay. Now you're given plenty of space, but there's quite a lot of working. Okay. So let me just copy that down. Y equals okay, given that, so this is section 17.8, quadratics. Sketching quadratics in the factorised form, and that's the form you got it. Okay, 17.8. Okay, so got a quadratic in its factorised form. What we're looking for, well, most obvious thing you can look for is the roots. Okay, roots are where it crosses the x-axis. Okay, find the roots by taking the brackets and equating them to 0. So one bracket equals to 0, another bracket equals 0, and then you solve for x. Okay, that's the x coordinates of your roots. It crosses the x-axis when y is equal to 0, so your roots for that. That's the first 2 coordinates of your graph. Okay. The turning point happens in between your 2 roots, in the middle of your 2 roots. Okay, so the shape of this parabola, the shape of the graph, is symmetrical. Okay, so the shape is symmetrical. So on the right hand side it crosses the x-axis, the same distance away from the turning point as the left-hand side of the parabola. Okay, so your turning point is just your x-axis is, oh sorry, the x-coordinate of your turning point is halfway between your two roots. Okay, so you find that by adding them together and dividing it by 2. So your x coordinate, your turning point, is 1. So it turns at 1. Now that's not enough. You then need to substitute x equals 1 sub into your original formula. So y equals, when x is equal to 1, oops, minus 5 plus 5. Okay, remember the two brackets beside each other. We don't write it, there's a wee multiple in between them. Okay, so that means they're multiplied together, so you're getting minus 25. So your turning point is x is equal to 1 and y is equal to minus 25.
Can you just go back up a wee bit so I can take a picture of it? Is that all right?
Yeah.
I just missed that a bit. Okay.
Okay, so your x coordinate of your turning point is halfway between your two roots. Okay, so that's us found the turning point. We've got two roots. We also want to find where it cuts the y-axis. So when it cuts the vertical axis, it cuts the y-axis when x is equal to 0. Okay, so the vertical axis and the horizontal axis, okay, they cut where it's 0. Okay, so where the graph cuts the y-axis, we say x is equal to 0. Where it cuts the x-axis, we say y is equal to 0. Okay, so when x is equal to 0, y is equal to x minus 6, x plus 4. We substitute that in. Okay, so y is equal to 0 minus 6, 0 plus 4. Okay, again, the multiple sign. Y is equal to minus 24. Okay, so it cuts the y-axis when x is equal to 0 and y is equal to negative 24. Okay, so we've got the roots, we've got the turning point, we've got the y-axis. Seems like a lot of work. That is a lot of work for 3 marks, but you need to do it. Okay, it's not, when you've done a couple, it's not hard. Okay, the shape is dictated whether the x squared term pardon me, if it's positive, then you've got a smiley face. X squared is negative, unhappy face. Okay, so the shape of your parabola, which is just what we call that shape, if its x squared term is positive, then it's a smiley face. So the x squared term is negative, it's an unhappy face. Okay, so if we've got y equals y minus 6, x plus 4. If we were to break that bracket and get the x squared term, then we'd have x squared minus 6x plus 4x minus 24. Okay, now we don't, all that doesn't matter. Okay, we're only interested in the x squared term. The x squared term, if we broke that bracket, is positive. Okay, you don't need to write that out, you just need to state it. Okay, it's positive, so the shape of it is going to be smiley face. So we've got everything we need. We've got a turning point, we've got where it crosses the y-axis and where it crosses the x-axis. All you need to do now is sketch it. Okay, now there's no scale required in this, but do it neatly and label it. Okay, so if we go back through 4 points, crosses the x-axis at -4 and 6. Okay, right on the coordinates. Those two coordinates are its roots. Its roots are where it crosses the x-axis, the horizontal axis. Okay, it crosses the x-axis when y is equal to 0. Okay, we've also got the y-intercept. It cuts the y-axis when x is equal to 0, and that was equal to -24. And the turning point, okay, the turning point was -1, no, it wasn't. It was +1, -25. Okay, that's all the information you need to be able to draw in the parabola. Okay. Again, that doesn't have to be in the calculator paper. That can be a non-calc question. Surprised it is in the calculator paper. Okay. Any questions on that? Okay, 17.8. Two more questions in the calc. This question was pretty catastrophic. Okay, what have you got in front of you? You've got the tan graph, okay, that we should recognise. Okay, so we've got the tan graph starting at 0, and going up to infinity. At 180, going up to infinity, 360. Okay. So we should recognise the tan graph. We've got y equals 3 tan x. Now, the amplitude doesn't really matter in this case, okay? 3 tan x. What we're looking to do is where the two lines intersect. We've also got a line, y equals -1. That's just a horizontal line. Okay, it's a blue line there. It might not be very clear. Okay, what we're looking to find out is determine the first time the graph y equals 3 tan x intersects y equals 1. So we've got y equals this, and we've got y equals that. Y equals both of these things, therefore -1 equals 3 tan x at this point. So we need to equate these two things. We need to bring them together. Okay, so 3 tan x is equal to -1. Y is equal to y. That y and that y is the exact same. Y equals y. So 3 tan x equals -1 at that point. Okay, so we've got that equation. Now we're rearranging to find x. So tan x is equal to -1/3. All we've done is move this over here. 3 tan x, 3 times tan x. It's a multiple on the left hand side, it moves over. Now, at this stage, we want to understand what quadrant that we're working in. Okay, so the tan graph is positive in here. Okay, so the red line, the tan graph, is positive between 0 and 90. So when x is equal to 0, all the way to x is equal to 90. Oh God. Tan is positive. Between 90 and 180, tan is negative. So between 90 and 180, so when x is 90, between that and 180, tan is underneath the x-axis, so it's negative. Between 180 and 270, it's positive. Between 270 and 360, it's negative. Okay. That's what this quadrant system is. Okay. So tan is positive between 0 and 90, negative in here, positive between 180 and 270, and negative between 270 and 360. So this cast diagram reflects what the graph is showing. Okay, so what is happening between 0 and 90 for the tan graph is positive. What is happening between 90 and 180 for the tan graph is negative. Between 180 and 270 is positive. 270 and 360 is negative. Okay. Why is this important? This, the intercept we're trying to find, okay, is when tan is negative 1/3. So we're looking for an answer when tan, the graph tan x, is negative. So graph tan x is only negative between 90 and 180 and 270 and 360. So that only that x, that y equals -1 only crosses when the tan graph's negative. So it crosses in between 90 and 180 and intercepts between 270 and 360. So it has to intercept in between the second quadrant and the fourth quadrant. So second quadrant and the fourth quadrant. Okay, so we are solving for x. We want to know the x coordinate. So we want to know what the x coordinate is. So we're going to bring tan over to the other side. And importantly, we don't need the negative sign in this calculation. So in your calculator, you're doing tan to the -1, 1 divided by 3. So the negative sign disappears. The negative sign allows us to take our answer, which is 18.43. Okay. And then work out what quadrant that we're working in. What quadrant is tan negative? Tan is negative in the second quadrant and the fourth quadrant. Tan is negative in the second quadrant between 90 and 180 and between 270 and 360. Second quadrant, we're taking that 18.43 and we're taking it away from 180. Fourth quadrant, taking 18.43 away from 360. Okay, so the line y equals -1 crosses for intercepts y equals 3 tan x, when x is equal to 161.57, okay, and when x is equal to 341.57. Close enough. Okay, so that line, that interception point, happens at 161.57 and when y is equal to -1. Determine the first time, so we're only looking for that answer. Okay, just follow the process, work out the second one as well. Only looking for that answer. I lost anyone. Determining where lines intersect is a big one. It can come up in a straight line, it can come up in simultaneous equations, which it did do in the past in the non-calc. It can come up on parabolas and it can come up on your trig graphs. So understanding what I mean by when working out how to find the point of intersection is really, really important. Okay, so this can happen in sine graphs, tan graphs, cos graphs, straight line graphs, or parabolas. Okay, trig graphs, you're using the cast quadrant system. Okay, all the graphs, sine, cos, and tan, know how to draw them out. Okay, know when they are positive and when they are negative. You do not get given the cast quadrant. So you need to know that. What section was that? 21. Trig functions, sine graph, cos graph, know them. Finding the equation of a trig function, y equals a sine bx. A is the amplitude, b is the phase, how many waves. In fact, that was in the non-calc, wasn't it? Draw that out. Okay, know how to draw the graphs. A, the number in front of the sine or the cos is the amplitude. That is where your maximum and minimums are going to be. B is how many waves between 0 and 360. That's what we just did, 21.3. Okay, section 21.3, solving the equation. That's what we just did. There's not much more that they can ask you there. Okay, once you get that, and once you get that drawn part of it, then you've got trig. Okay, the trig identities is separate altogether. Okay, I told you that was the most missed question. Okay, don't think anyone got that in the non-calc. Okay, so 21.3 is what we just did there. Okay, that's when we use this cos all sine tan, the cast diagram. Any questions on quick? Tell you what, not leaving a lot of time for the non-calc, am I? Okay, question 13. This was not done well. Question 13. Okay, so there's a lot going on. They love a wee question in regards to a shape in a shape. Okay. What we are doing here is we're having to come up with essentially two algebraic equations. Okay, and then multiply them together. Okay. So what we're trying to prove is that the area can be given by this formula. So this on the right hand side is we're trying to get here. This is where we want to finish. So whenever you see show that or prove or whenever you see show that, this is your start point and this is your finish point. Okay, so you're given the answer in the question. You just need to get there, which is the hard part. So we need to take the area of a rectangle and we need to get to this 4x squared minus 32x plus 60. So all your data is in this. So Sandy found a small photo frame and decided to put one of her favourite photos in it, which is lovely. The diagram below shows the dimensions of the frame. Fortunately, the glass in the centre of the frame was cracked and had to be replaced. So what they're doing is we're looking for a formula that gives the area of the inside shape. Okay, show that the area of glass needed for the centre of the frame, so that white area, can be given by this. Now, area of a rectangle is just length times breadth. So that's our starting point. Okay, so our starting point for this is the area of a rectangle is just equal to the length. Oh, can't spell length. Times the breadth. So we're looking for an expression for the length and an expression for the breadth for the inside shape. Okay. Now, length and breadth, it doesn't really matter which one you're starting with. Okay. But the total length of that outside rectangle is 10 centimetres. Okay. The inside length is 10 centimetres, but we're taking away one x and another x. Okay, because the thickness all the way around is x. So the length is 10 minus 2x. So the length is 10 minus 2x. Have I lost anyone? Breadth in that case. Total breadth of the whole shape is 6 centimetres, but we're only looking for the inside, so it's 6 minus 2x. So it's x on the left hand side and x on the right. So we've got an expression for the length of the white area and an expression for the breadth of the white area. The area is length times the breadth, so we need to multiply 10 minus 2x by the 6 minus 2x. Okay. Have I lost anyone? Okay. So we came up with an expression for the length. And the breadth. Okay. So the area is equal to length times breadth. So length times breadth. And then we multiply it out. Rearrange it in the format where we know. And that should equal that.
Where did you get the 2 from again? Like the 10 minus 2 and the 6 minus 2?
So the 10 minus, there's 2 sides that were taken away, okay, and each side is x centimetres. So it's that. So the length would be 10. Oh my god. Minus 1x minus another x. So minus 1x minus another x.
Ah, right, okay, yeah.
So we're taking away this green bit, and we're taking away this green bit to be left with this length here. So total from the top to the bottom is 10. We have to take away this bit and this bit to be left with that. Similarly, in that breadth, okay, the full length is 6. We're taking away this, which is x centimetres, and we're taking away this, which again is x centimetres. Okay, so it's 6 minus x minus x. To get us that. That's 4 marks. Okay. They like making you make your own equations up. Okay. they like to create or form quadratic equations. Okay, so this is another example. Length times the breadth. So you have 2x here multiplied by a bracket, and then you're working through. Okay, they like you to create your own quadratics. That's what we did there. This can sometimes mess with your head. It's sometimes awkward. It's sometimes one of those ones where you might need another attempt at. You start it and you go away. Yeah. Right. Last question in the calculator. If the area was 34 centimetres, find a possible value for x rounding to one decimal place. So we've got area is equal to 4x squared minus 32x plus 60. We've been told that the area is equal to 34 centimetres squared or something. 34 centimetres squared. Okay, that means we can write that as 4x squared minus 32x plus 60 is equal to 34. So we are looking for values of x where that equation would work out to be true. So we're looking for a missing value. Okay, now to do that, we're effectively finding the roots of that quadratic. Now in your calculator paper, especially when it says to a certain amount of decimal places, we're using the quadratic formula. Okay, you will not be able to factorize this in your just by writing it out. You need to use the quadratic formula. So we have an expression that we can equate to 0. That's the first step that we do. Okay, so we've got 4x squared minus 32x plus 60. We're bringing that 34 over. So the right hand side is equal to 0. Just tidy that up. And now we've got it in the form. Okay, that's the form that we need it in. That means we can extract what A is, what B is, be very careful of the sign, and what C is. And why I've done that as a negative, that should be positive 26. Okay. So we're looking for values of x where that's be true. Oops. Using our quadratic formula. Okay. Now A is equal to positive 4, B is equal, and be very careful here, it's equal to negative 32, and C is equal to positive 26. You're substituting these letters in. Okay. X is equal to negative b. Well, b is negative 32. Negative and negative, that would become a positive. Okay. As I said, when we're doing this, you can pull that a wee bit to one side and just do it at the side so you don't make any silly mistakes, and then just put it back in, slide it back in. Okay. That's your discriminant. At this point, we split it up. Okay, and we split it up so we've got two different equations. One where we plus the root b squared minus 4ac, and one when we take it away. So on the left hand side we've got x 32 plus root of 608 all over 8. And here we've got x equals 32 minus root 608 over 8. Okay, what might throw you here is there's two answers. Now what sometimes happens is one really obviously is correct and one's wrong. Okay, neither jumps out at me as being right or wrong. Just leave it as is. Okay, that's your two answers. Don't think many people did that, i.e. do the quadratic. Okay, as soon as you see a quadratic and it's asking us for decimal places, quadratic formula. So anything in the form ax squared plus bx plus c, we're using the quadratic. That is section 17.7. And that, my friends, has been 2.5 hours, which is spectacular. I'll post this video, take it away, digest it, think about it. What I wanted to do on Thursday was another formal sort of prelim. Okay, now for two reasons: for further practice and because some people weren't able to do it last Thursday. What we've not done is a non-calculator paper. So I'll record that tonight. I won't make you sit on it, sit here. I'll record the result, I'll record the working for that, and I'll post that as well.
Are you going to give us back the papers for us to look at for one of our answers and stuff?
I'll give you them on Thursday. when you're leaving, and I'll let you take pictures of them. That's
Okay.
all right.
Yeah.
So I'll have them available for you. If you don't want to do another formal sit down, if you don't see any value in it, if you don't reckon you'll improve, whatever, okay, can't force you to do it. Okay, so if you come in Thursday, we'll do a formal sit down prelim. Okay. In the same structure. So we'll just do that at 6 o'clock to 9 o'clock again. I'll post this video and the one for the non-calc first thing tomorrow morning. Yeah, then digest it. And then it's up to you if you come on Thursday or not. Alright, it's worthwhile. Because that's then Easter, so after Thursday, nothing next week, nothing the week after. I'll post the working of the prelim we do on Thursday. Okay, so I'll do that and I'll post a video of the working of that, so you've got that. And then I'll point you in the direction of some, well, past papers. Okay, so do the past papers, 2014 to 2019. Remember in the email, there was the questions, or the email from a couple of weeks ago, the questions that you don't need to do. Okay,